Okay, so in this case, we're going to show that two matrices are inverses. Well, to do that, think back to like when you have 2 times 1/2, that just equals 1, right? And 1/2 times 2, that equals 1. These 2 and 1/2 are multiplicative inverses for real number multiplication, right? Real numbers. But now we're going to do the same thing with matrices. So what we have to do is we have to show that matrix A times matrix B equals the identity matrix. Okay, not 1, but the identity matrix. And B times A also equals the identity matrix. Okay, now we're going to be working with 2 by 2s. So our identity matrix is going to be 1, 0, 0, 1, like that. Okay, so that's what we're showing. Okay, so I'm going to first do AB. So AB is going to be 1, 5, -2, -9 times -9, -5, 2, 1. And then we know what we're supposed to get. But again, this gives us practice in multiplying. The 2 by 2s, they're not as bad. The 3 by 3s, those are a little bit more work. But 1, 5 times -9, 2. Okay, so 1 times -9 plus 5 times 2. 2. Okay, I was ahead of myself. Now, first row, second column. 1 times -5 plus 5 times 1. Okay, now we switch. Second row, first column. -2 times -9 plus -9 times 2. That one's hard to keep track of. Remember, you're going this number times that, and then, and then this number times that, okay? So I always think like I'm taking the -2, -9, this, and I'm lining it up next to the -9, 2. And that's the multiplication, and then we're adding those together. Okay, that probably doesn't make sense to you, but that's what we're doing. I wouldn't write it that way, but okay. Now I've got to do second row, second column. So it's the -2 times -5 plus -9 times 1. So it's very visual with that multiplication. I think of the row like being flipped up and matching against the column in the other matrix. I don't know if that helps. All right, let's see what we get. We know what we're supposed to get. Okay, so -9 and 10, that is 1. You could write up here -9 plus 10 if you want to see it. -5 plus +5, 0. 18 plus a -18, 0. And then 10 plus -9, 1. Yep, that worked. It's the identity matrix, so this is an identity matrix dimension 2. Okay, now we have to go the other way. So we're going to switch them and go BA. So we're going to have -9, -5, 2, 1 times 1, 5, -2, -9. Okay, so we switched the order now, and it should work. Let's see what happens. So, oops. Put my bracket there. So first row, first column, -9 times 1 plus -5 times -2. Okay. First row, second column, so -9 times 5 plus -5 times -9. Now we'll go, it's really hard, there's only 4 elements in each matrix, but you got to keep track of like which one's matching to which. And anyway, the second row times the first column, so that's going to be 2 times 1 plus 1 times -2. And then the second row times the second column, which is going to be 2 times 5 plus 1 times -9. Okay, and because these are 2 by 2s, it's a little bit easier to write. I can write above the calculations, so that might help you. -9 plus 10, yep, that's a 1. And here we have -45 plus 45, that is a 0. And then here we have 2 plus negative 2. That's also 0. And then here we have 10 plus a negative 9, which is 1. So yes, it worked. Yay, smiley face, check mark, whatever you want to put. You've shown that the multiplication, that A and B are inverses. I'll just write A and B are inverses.